Action.
Right, that's my time up. Thank you very much. I was reading a paper which was about knowledge extraction based on combining ontologies and linguistic text analysis. And I think this is the thing that improves the tweetbot thing that you guys have got, because the problem that we had was that that was transcribing the text. So ignore the transcription part. That's also a hard problem that you need to get right and have decent acoustics and everything. But then it was just looking at the text and going, what are facts? What is true? And it was making up all sorts of assertions that were just based on finding words in reality with is or was or has or something in between them. And so we got some very comedic but ultimately not very useful information out of this. What we want to do, I posted a comment from someone on a mailing list someone who was talking about building a chatbot, and they were saying make it more like a puppy and less like a human, so that people have that level of expectation. A puppy can fetch your slippers, it can't cook you a casserole. So make it more clear what the constraints of the problem are. And this paper, which is fairly old, 2005 I think, was talking about combining. So on one side we've got our model of the bit of the world that we're interested in, and we already know how to focus that model.
We can cut this out in post.
Yeah.
Do you need to change the size of your pen or something?
How do I?
Right.
Oh yeah, this thing. Right. There we go. Fine marker. Good. So over on the right hand side of the thing, we've got the ontology. Yeah. Which is the thing that tells us what there is in the world and what relationships there are and what we care about, and we can use that to describe our view of reality. And this paper was using a format called a topic map. Now, a topic map is a hypergraph, which is like a graph but more awesome. I'll leave that there because there's a whole side discussion in what that is. On the left, we have our document, our transcription of what someone has said, or our CFP textbook if we're trying to learn how to pass the exams, or whatever our source of text is. And we can put that through a system that will give us some I think it's just called linguistic extraction, and I'm going to use the word linguine because it looks like linguistic but it's shorter, and I only gave myself a little box. So we can go from text to things that are expressed in a text, and we can go from ontology to things that we're interested in. So what we want to now do is a bit in the middle called knowledge rules, where we say, given what we understand of the ontology and given what we worked out from the linguistic extraction, let's apply the constraints that are in here. This is the collection of facts that we want to know and the collection of things that we know about them that restrict what could possibly be either relevant or true out of the linguine. So let's build a collection of rules that express this ontology in terms of these linguistic relationships, and then when we put the text through there, we only get rules that match what's in the topic map. What?
Doesn't the topic map restrain the ontology?
No, the topic map is an expression of things that are true in the ontology.
Oh,
so
okay.
the ontology says something like, a person has multiple pensions, and the pensions are provided by multiple funds which are managed by multiple providers. And the text says, oh hi, I'm trying to get some advice. I've got like this workplace pension which was from Oxford University from about 15 years ago, and I've got this other thing from Legal and General that I've had for ever since then, and I want to know like what I should do. How can you help me? And the knowledge rules say, well, if you've got a thing that connects a person to a pension, then we care about that. And if you've got a thing that connects a pension to a manager, then we care about that.
Yeah, that's in the ontology, right?
Yeah. So the ontology says a person has 0 or more pensions. The linguine says the person 15 years ago worked at Oxford University. The person has a pension from Oxford University. The person wants information about financial advice. And the knowledge rules say how we map these facts onto this ontology so that we can populate this topic map, which is a statement of expressions that conform to this ontology and were extracted from this text.
Got it.
Oh, cool.
So this is
the topic map is the data about
the topic map is the database. Yes, it's just represented in a particular way where you have so you have like topics which are kind of things or events, and relationships between topics, and then like instantiations of topics. So it might be that this is a person, and so it's it's Bob who phoned us up, and this is person has multiple pensions, and this is the pensions that they told us about over the phone.
Cool.
So
That is a realization of a topic map.
So you could then use that topic map to like pre-populate part of a fact find or whatever.
Yeah, absolutely.
Like,
In fact,
kind of identified.
you would say that the topic map is the fact find at this
Right.
point. Like,
Okay,
it is the information that is true that maps the so everything in here is things that you have worked out about like the content of this text, whether it's phone transcription, chatbot, or whatever. This is the things that we care about, and this is the thing that lets us extract things that we care about from things that are true, and this is the document that represents that learning, basically.
Yeah. Oh, nice.
Now, because this paper, I can't remember, I think it's about 2005, it might have been earlier, and because semantic web, this is XML, this is XML, this is XML, and this is XSLT, which is just a way of turning XML into other XML. There's no particular problem with that. I don't have a problem with that. But this was also manually constructed. So my question for the rest of the group is A, can we use this? And B, can we somehow learn this without having to supply it as a as typing some XSLT. I hate writing XSLT, even if using it is a reasonable activity. That is the presentation. I will put a link to the paper into the into comments in the meeting notes, so you can all see that.
Cool.
And now I open to cross-examination.
I'm interested in the linguine extraction. That's the fact extraction we're using before. So I guess you're saying the ontology would be used to sort of because that was outputting a load of nonsense facts. Part of that was actually do with the speech to text, but ignoring that, it still does produce nonsense facts. So is the ontology saying, okay, in the subject relation object, we're going to cross-validate the object. It has to exist in the ontology in some form. So if somebody says I have a dog, obviously we don't care. So it doesn't get put in that topic map.
So
is that what? I'm just trying to sort of rephrase it.
It is doing exactly that, and it's also doing knowledge of what can possibly be true within the book.
Okay,
so if I said, so I've got a pension that's managed by LNG and Friends Life and the University Superannuation Scheme. But our ontology says there's only one fund manager per fund. Like, we know that was not a fact that was correctly extracted from this text, either because the source text was wrong on this count, or maybe our ontology is wrong, or maybe this extraction failed. But we've got a thing. So yes, it's limiting us to things that we care about, but it's also limiting us to things that can be true within our model of what we care about, and that also has value.
So it seems like the core thing to solve then is, so ontology will say a pension has a fund manager. So in our knowledge rules it needs to say, here's some example of loads of fund managers, here's an example of loads of pensions, GPP, SIP, fund managers, Aviva, Scottish Widows, So that feels, so I guess in a really simple way we could have it, if we don't think of examples in work, or we could use some kind of like name density recognition or something to try and guess, well, Aviva is probably a fund manager.
So you don't need a priori the list of all possible examples, because knowledge extraction from text can just take, like Joe's example was a kind of subject verb object, so like a predicate. It can take that and populate it just based on what it knows of the shape of the predicate. So if I said I've got a pension and the fund is managed by ASDA, then ASDA would be a pension fund manager in our topic map,
because the managed,
even if we'd never heard that ASDA run pensions before.
Yeah, we start to know that managed corresponds to that relation.
Yeah. Anything else?
So we would train some kind of classifier based on, we'd work some examples of this with the ontology and how it maps, and then
and so we'd look for building a set of rules which, like I say, in the paper is done manually, but maybe there's a better way to do that. We would look for building a set of rules that give us the best fidelity in our output document, which is as with all of these things, minimizing the trade-off between type 1 and type 2 errors. So do we correctly determine all of the facts that are there without incorrectly determining facts that aren't there?
So is the rules, because I thought in the ontology it would be a fund has managers.
Yeah.
But is that in the rules?
No,
So what's an example
yes,
of a rule?
The answer is yes. The ontology is the thing that tells us that a fund has a manager. The knowledge rules tell us how to determine that someone told us that, given the text.
The knowledge rules, given that it's an XSLT, is really just a transformation between one data type and another. Isn't it? So on the left we've got a load of subject, verb, object, what are they called? Triples. That we then need to turn into whatever that thing is on the right, which is a graph, isn't it?
Yes.
So XSLT is one way of doing that. I don't think it's a particularly elegant way of doing that.
No.
I wonder whether there's some kind of learning technology that we could use to...
Absolutely. The reason that they use XSLT is partly that ontologies are expressed in OWL, which can be written in XML, and partly that this thing is actually a kind of it's a hierarchical structure. So we might work out that Bob is the person. Bob has the pension. Bob has the pension that's managed by whoever, and so you can use XPath on this side to extract like deep nesting. And you can use XQuery on this side to generate to discover relationships, and then you can combine the two. But that's all because it was written sometime after the middle of the 1990s. It's not that XML technology is not like a critical part of solving this problem. It's just
what's the weakness with the linguine extraction with the data as it's presented in there? Because in there you've got you've got this concept that Bob has a pension, and you've got this concept that the pension is managed by Asda. Why do we need to transform it into the topic map?
So that you've captured here the relevant facts with the relevant constraints that are useful for solving your problems. Because you've also got in here that, like, as there is sunshine outside, and that a dog is sick of pension advice or whatever. And so it's about kind of selecting for relevant information from a sea of potentially true but useless or false and useless facts that were gathered from this text exploration.
You're just filtering the data, basically.
So it's about understanding, because on the left, if you've got Scottish widows, I have a GPP with Scottish widows, right? That doesn't really mean anything unless you know that GPP is a pension and Scottish widows is a pension provider.
Okay.
So the ontology.
Yes, this is information, this is knowledge, this is wisdom.
Is it wisdom? Tell me how it's wisdom. If this is a binder, then.
Well, so this is about being able to synthesize actionable information given, like, any old information.
Right, that's good. I've got to give you that. Good. So have we heard of any technologies that do relevance scoring?
Relevant scoring?
Yeah, so here we've got a bunch of data on the left, lots of which is relevant, and we only want to take the stuff which is relevant above a particular threshold over onto the right. Is there any better way than XSLT that we've heard of?
Well,
because when you search on Google for a particular thing, they give you back pages plus a relevance score, don't they?
Isn't that just a classifier?
yeah,
Like the closeness that it matches to something.
yeah, we could do some simple matching, like you could have multiple relations that use different words, but they are the same relation, like has and owns. They're both the same thing. You can just match. You could either do cosine similarity or just give all the examples you could possibly have of owning or of having that, and then you can just. But again, that's writing all the rules manually, so maybe it's not quite the thing you were getting at.
This feels like a NLU problem, right?
Yeah, I was just.
Oh yeah.
Like on the linguine,
Yeah.
you have like lots of things like dog is an animal, whatever. Or so GP, I have a GPP with Scottish widows, and in that our kind of almost our intent is a relation in the ontology, and the entities that we're extracting are Scottish widows is a pension entity, a pension provider entity, and GPP is a pension entity. So it feels like a very analogous problem that's already kind of well solved.
Could we use RASA?
Yeah, potentially.
Yeah. So we give it some examples of, I have a pension with blah blah blah, and word that in different ways, and then it can infer the other examples.
Right. Yeah.
But is that bypassing the need for everything?
No, because we still need to decide which of those are useful, and how they fit into the topic map. Into the topic map is defined by the ontology.
I suppose, like coding all of that is kind of manual. Like we'd have to manually code out that the first few examples.
Yeah.
So it's whether we can learn that.
We can do like online learning, as in like interactive learning.
Yeah.
It works fairly well.
Yeah, this paper was specifically applied to court proceedings in a particular type of court case. So the source text itself was fairly well structured. It had free text sections in it. But you knew what was going to turn up in those free text sections, so it kind of constrained this side more than like searching Google. You cannot make any, you cannot have any preconceptions about the text that you find, web page if you're building a search engine, but you can if you're searching court proceedings. Right.
Cool.
Okay, cool. Nice one. Thanks, Andre.
Okay.